Hey guys, Danny here. Welcome back. So today in this video, we are going to be looking at computer vision. We're going to be talking about computer vision in general and what exactly that is and what you can do with it. But we're also going to be playing around with using the webcam in P5. So the origins of computer vision really start with the barcode. So the barcode is basically it's just binary. So basically how it works is when the scanner or a laser hits these lines, it bounces back information to the reader. And when there's a black line, it's basically in binary saying this is a 1. If it's a white line, it's a 0. It's kind of like on or off. So that's all that's going on here. And based off of that variation on lines, you can create different codes. So today there are a ton of versions of the barcode out there. These are just a few of them. So there's also background subtraction. So you see this a lot in movies and TV shows where there's a green screen or a blue screen, and that gets replaced with some sort of CGI digital element. So they do live action in the foreground, and the background is a green screen or blue screen that gets taken out and replaced with a digital environment. So you could do this with more complex backgrounds as well and more complex environments. It doesn't have to be a blue or green background. It's just a lot easier if the background is the same color or consistent value to remove it and replace it with something else. So you could play around with threshold and different ways of manipulating the image, and especially if it's a static camera. So the background is constant, but there's people walking in front of it that's breaking apart the background. You know that background is going to be a constant, so you can take that away. So that's being used a lot, especially these days since everyone's social distancing and in quarantine due to the pandemic. A lot of people are using Zoom, and I believe one of the reasons why Zoom became so popular versus like Google Hangouts or some of these other platforms is that it allowed you to change your background and put in an image or video to replace your background. So they're using background subtraction technology to replace the background with a different image. So I did this for a project of mine called Bocce Draw with a friend of mine. Let me play this video and I'll explain it as it goes. So this project is all about bocce ball. We decided to add some technology to the game of bocce. So we built our own court, and there's a camera above the court that's detecting where all these balls are. And it's basically just using basic background subtraction. So we know the background is a constant, and then anything that interrupts that background we know is a new object that we can analyze and do something with. So the balls are being detected by the camera and by the computer that it's hooked up to. And I'm basically determining the distance from the little white ball called the Polino with the player balls. So this game is all about distance, so the closer you are to the ball, you get a point for that. So for some visual elements, we also added a projector that projects these graphics onto the court below, so you know where you are, who's closest, and who actually gets the point in the end. So this is the rig. This is what it looked like above the court. There is a projector mounted, projecting onto the court, and there's a PS3i camera here, which was then connected to a computer. So this was doing all the computer vision stuff by detecting when something entered the scene, so when a ball entered the scene, and then calculating the distance of those balls from the smaller ball. So you could also use background subtraction as a way to make your own touch screens and touch interfaces. So Potion Design is an agency in New York that uses this a lot when it comes to interactive installations at like bars or museums or galleries. So they're using background subtraction and computer vision to detect when a finger is touching a specific location on a surface. And they're also using projection to create a interface for that interaction. So this is overhead projection that is projecting the graphics on this table. And then when you press down on a specific element on that projection on that table, there is a camera above the table that's detecting when a finger is close enough to that particular area. So for this example, you can see that the projection is above the table, but you could also do a rear projection. So this is another example by Potion that has cameras underneath this plexiglass, and then also projectors underneath this plexiglass. So all the projection is coming from underneath the table. So you can use cameras that are above a table or underneath a piece of plexiglass, and then using some simple background subtraction and some thresholding, you can determine when someone is actually pushing their finger on a specific area and moving their finger around. So another thing that you can play around with computer vision is fiducial markers. So these are kind of like barcodes. So it's kind of like QR codes, something like that. And that could be detected by a computer and a camera. And then you could do some interesting like augmented reality stuff. So doing like overlaying other content on top of this fiducial marker. So one example is a project that was commissioned by Doritos, which is they had a fiducial marker inside of their Doritos bag. And you can hold that up to your webcam, go to a website, and it'll play a semi-live show inside of your bag. So here's an example of that working. Let's skip ahead. So webcam, you go to a website. Hold up the bag to the webcam, and it detects this marker, and then it overlays more content on top of that marker. So it's giving you a concert on your bag, basically, with a number of different bands. It's also interactive, so when you shake the bag, it drops bricks and like moves different elements around, which is pretty cool. So there are a number of different platforms that allow you to do this fairly easily and allow you to create your own fiducial markers based off of images, which is great. So rather than using like a QR code or something like that, you can just take a picture of like a poster and then use that as your marker. So when you hold up your phone or your webcam or whatever to that particular poster that you just took a picture of and uploaded and kind of scanned, then it will detect that you're looking at that, and then it can overlay more information on top. So some of the platforms that I've used in the past are Blipper, Layer, and Vuforia. So here's a project I did for the Walters Art Museum in Baltimore that uses the Vuforia SDK. So basically, when you have this app on your phone, you hold up your phone to a particular object in the museum. It detects what you're looking at and overlays more content onto it. So in this case, the curators of the museum knew more information about this particular relief. Through chemical analysis, they knew what colors it was originally painted. So rather than just putting it on the plaque on the side, it made more sense to make it a little bit more interactive and engaging. So when you hold up your phone to this relief, it overlays the original colors on top of it. Here's a demo reel that Vuforia put out that is around smart terrain. So basically you can scan an environment like your coffee table and the objects on your coffee table and turn that environment into like a gaming virtual environment. So you basically just scan an area, and you can do like 3D scanning. And then you can add more digital content on top of that. And then walk around, kind of go in and out and see what's going on in that digital environment, which is overlaid on top of that physical environment. So this is a really interesting topic. Facebook has kind of mastered the deep face facial recognition algorithm, just considering all the information that they have. It's looking at a lot of different details when it comes to an image of a person's face. So this is kind of how they break it down. They look at they detect if it's a face. They break that face down into multiple elements and data points. Look at it in different angles, look at it in different lighting and different shading, etc. And they also have a mass amount of information. And based off of this data, based off of all these images that we're all uploading to Facebook constantly and tagging, it's amassed this database with millions and millions, billions of data points in it, which they can then use for some machine learning and artificial intelligence to sift through all that data and use it as a way to detect when it gets a new image and suggest who's in that image. So it's pretty intense what they can do with facial recognition now. So when it comes to what we can do a lot of this stuff too. So there's a library for processing called OpenCV, which is an open computer vision library for processing that allows us to do simple things like face detection. You could do more advanced stuff. There's a plugin called Face OSC that was created by Kyle McDonald that we can also run in processing and collect the data from processing. So we can detect that there is a face, and then we could also detect facial expressions and like how big your eyes are versus how big your mouth is, head tilts, three-dimensionality, all sorts of stuff like that. So here's an example of, this is Kyle McDonald, and he's kind of demoing what you could do with it. This is called face substitution, where he's detecting his own face and then overlaying someone else's face on top of it. So this was done probably about 10 years ago, and there's tons of other apps out there that are doing this now, like Snapchat and Instagram filters. So this is pretty prevalent now, but 10 years ago, this was pretty ahead of its time. So another example is Kyle McDonald's font face. So he's using Face OSC as well, but rather than replacing his face or doing something like that, he's applying it to a letter form. So you could do some pretty creative, interesting stuff with it. Essentially, it's just data that you can apply to something else. So another thing that we should talk about when it comes to computer vision is depth and detecting depth and three-dimensionality. So there are a few different technologies that you can play around with this. So there's radar, there's sonar, and then there's LiDAR. So one really interesting creative application of using LiDAR was Radiohead's House of Cards music video. This was actually shot entirely on a LiDAR machine, 3D scanner essentially. So again, the LiDAR machine is just shooting out a laser and bouncing that laser off of something and measuring the time that it takes for that bounce to occur. So the distance essentially from when the laser was shot out to when it bounced back. So that's what's going on here. All those pixels are just data points from a LiDAR machine. And they did some interesting techniques for distortion. They played around with shooting it through a plane of glass and like pouring water on the glass, or dropping feathers, or kind of interrupting the laser beam's travel time essentially. But all of this was shot on the LiDAR machine, and no cameras were involved at all. LiDAR machines are a little more difficult to get your hands on, just because they're large and expensive. But we can use a Microsoft Kinect, which is basically the same thing. It's shooting out a laser, bouncing it off something, and then measuring the time that it takes for it to get back to the sensor. Another piece of hardware that you might be interested in checking out is the Leap Motion. So this is very similar to Kinect. It's using lasers to shoot out and measure the distance, but it's also much more detailed. So this is designed for like finger movement and hand movement. So it can pick up the digits of your fingers, so you can be very precise with the interaction. For the leap motion, you can connect that. There is a library that allows you to connect that to processing. You could also play around with it in JavaScript. It just shoots out a bunch of data for you to play around with in a JSON format. So here's an example of the Connect working in processing. So this is a example by Dan Schiffman, where it's basically just getting all those data points and then applying them to a point cloud. And then you can do whatever you want with those points. They could be points, they could be circles, they could be boxes, they could be different colors. So you can apply any sort of different design and stylistic element to those that you'd like. You could also do skeleton tracking with the Connect, which is pretty great. So if you want to do some sort of like game that requires the user to use their body as a controller and their movements as a controller, you could do some interesting stuff with that too. Here's a project by a friend of mine, Robbie Tilton. He recreated the Iron Man 2 interface using the leap motion. So you can use one finger to point using the leap motion. You can use both hands to kind of move an object around in 3D space. And then you could also swipe to the left and to the right to bring content on and take content off. So you could do, I think all of this was done in JavaScript, so you could do some pretty great stuff with this device. Here's another project. This one uses the Connect. It's called Firewall by Mike Allison and Aaron Shearwood. And it's basically just measuring the depth when someone pushes in on this elastic kind of wall. It applies that data to a musical loop or sound samples, and then also to these really beautiful graphic elements too. So the interaction is just that pushing, the measuring that depth. Here's another project that uses, I think, multiple connects in an interesting way. Again, it's an instrument too. So it's using the connects to do skeleton tracking and body movement detection. And based off of the movement of the user, it's triggering different sounds. And then also there's a projection on this wall in front of the user. So you could see some interaction there too. So one last project, this is Danny Rosen's wooden mirror. And this is using computer vision. There's a little camera inside in the middle here that is hooked up to a computer, and it's doing some basic analysis on the pixels of the video that it's seeing. Based off of that, it's adjusting the angle of these wooden little pixels up here. And when the angle is pointed up, it's brighter. When it's pointed down, it's darker. So you can see the image being passed into these wooden pixels, which is really beautiful. So there's the camera. And then each one of these wooden pixels has a little actuator associated to it, so it can tilt. And it's basically just tilting based off of the brightness of each pixel. So it's breaking the image down into grayscales, looking at the pixels, and then changing the degree of the wooden panel based off of that value. So there are a lot of other sensors that you could play around with when it comes to computer vision. If you want to play around with the Arduino and microcontrollers, you can hook up distance sensors to those. And then you can take that data and pass it into processing if you wanted to, and then apply it to something digital as well. So this is kind of a summary of what we just covered. So the origins of computer vision are in barcodes. You can play around with background subtraction when it comes to just webcams. You can play around with fiducial markers and QR codes to do some sort of like augmented reality. You can do more detailed stuff with augmented reality by scanning an environment or using something like Vuforia or Blipper to scan a poster or an object in real life and then use that as a fiducial marker. Then we can also do like facial detection, facial recognition stuff, and overlay more content on top of your own face, or use your facial expressions to interact with an interface. And then you could also play around with depth using a Kinect or a Leap Motion. You can measure a 3D space, take those data points, and then apply it to something else in processing. So what can we do with P5, since that's the main framework we're playing around with? Unfortunately, I don't currently know of any way to connect a Kinect or a Leap Motion to P5. I'm sure there's a way to do it, but there's no way to do it easily that I know of. There is a way to do it easily when it comes to using processing, though. So you can play around with the Kinect or the Leap Motion in processing pretty easily using a number of these libraries. So for processing, again, this isn't for P5. This is for the Java version of P5, which is the original processing. There is a library called the video library for processing to get a live video feed onto your sketch. There's an OpenCV library, which you need to install. There's a Connect and processing library if you want to connect the Connect to processing and get that data. It's called Simple OpenNI. There's a QR codes reader for processing if you want to play with QR codes and fiducial markers. Then if you want to play around with facial detection and facial recognition, there is the Face OSC plugin by Kyle McDonald, which you can download. It's free to use. And then you can also take that data and pass it into P5 using the OSC P5 library. So we're not going to be talking more in depth about any of these because we are using P5. We're just going to stick to P5. But if you are interested in playing around with any of this, this is kind of a good place to start. And you would have to use processing, the Java version. But for P5, we can do a number of things. So we can play around with the webcam and do some basic live video manipulation. We can do some stuff with Arduino and microcontrollers and getting those sensors to pass in data into P5. We're not going to do that, but you can. And then you can do some facial recognition stuff too, but that requires some machine learning knowledge, which we're not going to get into during this video, but my next video will be all about machine learning and artificial intelligence. So with that, we can do some more detailed stuff when it comes to facial recognition in that video. For today, we are just going to be playing around with the camera and capturing live video using our webcam. So you're going to have a webcam. That's one requirement. I think most of you, if not all of you, will have one. We're going to play around with the create capture function and pass in the video variable, which is basically a webcam or a live video feed. So the video is going to come in as a DOM element in HTML. So we could hide that if we just want to display it on our canvas. Then that's what we're going to do using the image function. And then we could also change the size if we wanted to using the size function. And then we could also do some analysis on the pixels of the live image using the get function. So we can get the colors of each pixel basically and play around with that. The first step is basically just getting the live video onto our canvas. So we are going to create a variable called capture. Again, it could be called whatever you want. In setup, we have our canvas. I am just doing it 640 by 480 because that's the webcam's resolution. Then we are going to set the variable capture to be equal to create capture and then pass in the video variable. We can hide the DOM video. So if we don't want to have the video in the DOM and then also the video on the stage, we can hide the DOM video. And then in draw, we're just going to have a background, use the image function, and then pass in the capture variable to that image function. You can set the X and Y coordinate and then the width and height as well. So let's go to the web editor. All right, so the first thing we're going to do is create a variable at the top. Let's call it capture. Again, it could be called whatever you want. I'm going to change the canvas size to be 640 by 480. Set capture to be equal to create capture. And we're going to pass in video into that function. And it has to be all uppercase too, so it's case sensitive. Okay, so let's change the background color to 0. And let's just play that and see what happens. All right, cool. So it creates a video element as a DOM element. So this is an HTML element. So we're playing around with HTML elements in P5 now. So if we wanted to use this and put it on our stage, then we can use the image function and pass in capture, set the X and Y and the width and height. Okay, hit play. So now I have the video and there's a DOM element, but it's also being displayed on the canvas of my sketch. So if we didn't want to have the DOM element here, then we can hide it. So let's do capture.hide. All right, so there is our video on the canvas. So the DOM element is gone. So now if we wanted to add something like an ellipse, and let's just put it right on top of my face. Let's do 100 by 100. Let's do a fill of white. Okay, so we got the video, and then we could add additional elements on top of this video too. It's basically the same thing that we did with the image. We're just passing in a live image essentially into this image function. All right. Okay, so let's delete that ellipse. So if we wanted to, we could also play around with like tint. Let's tint this red. Cool. So we can play around with tints on live images. We could also play around with filters if we wanted to. So let's play around with a filter as well. Let's do blur. Sorry, all uppercase. Blur and 10. Okay, cool. So as you can see, it's a little choppy, and that's just because it's processing a lot of information when you're using the blur filter. So let's stop that. That's basically it. So that's how you can get a live image from your webcam onto your sketch. And then you could just treat it like any other image by adding a tint to it or a filter and using the image function to display it on your canvas. Okay, so if we wanted to play around with the actual values of each pixel, just like what we did with images, we can do that too. So why don't we analyze maybe not every pixel, but a few of the pixels and loop through them, and then get the color value for those pixels and display them in ellipses. So let's play around with that. So we basically do the same thing that we did before for setting up the video. And then in draw, we are going to create a background. The S is a variable for the size of these ellipses that we're gonna be drawing. And then we're just gonna do the .get function to get the color of not every pixel, but every 60 pixels. And then we're gonna pass that color to the ellipse. And I'm gonna add a few things to this. So I'm gonna do an ellipse mode and do that at corner. Gonna do no stroke. And then I am going to delete everything but the background. And let's change that to white. Okay. Okay. So the next thing I want to do is create a variable for my S, which is the size. And then I am going to do a double for loop. So we're basically going to loop through all the pixels in the video and get the color values for the pixels that we want. Let's create a var x equals 0 for the for loop. X is less than capture dot width divided by s, and then x plus plus. And then we're going to do, like I said, double for loop. So we got to do the y now. So var y equals 0. Y is less than capture dot height divided by s. Y plus plus. Okay. So the first thing we want to do is create a variable for C for the color, and we're going to use the get function and apply that to the capture variable. And we're going to get x times s and y times s. Now let's just do a console log for C for a second. Make sure that's working okay. Okay, so we're getting an array of values. That's R, red, green, blue, and I think that's opacity. Okay, great. So that's working. Let's comment that out. So I'm going to pass that color to a fill and apply that to some ellipses. And the x is going to be x times s, y times s. The size is s and s. So this is going to draw an array of ellipses and apply the color from the video to those ellipses. Cool. So if I move around, then you can see that the colors are changing based off what it's seeing in the webcam. So I could put my finger over the webcam and then it all goes red. It's basically seeing my blood pulsing. Take it off and then it just sees me. If we wanted to, we can hide this capture or hide this hide. And then we could see the video below as well and compare it. Cool, that's good. So another thing that we could do is play around with the brightness value. So for that, we basically are going to do the same thing, except rather than just get the colors, we're going to add those red, green, and blue color values together divide it by 3, and that's going to give us the brightness value. In this case, it's going to be a variable of b. So we can take that and we can apply it to, in this case, the size of the ellipse as well. So why don't we do that? Create a variable for b, set that equal to C0, which is red, plus C1, which is green, plus C2, which is blue, then divide it by 3. And then let's just apply that b value to the size of the ellipse. We're probably gonna have to play around with changing that value based off of like dividing it by a certain number if it's too big, but let's see. Yeah, it's a little large. Okay, so let's divide it by like 10. So b divided by 10. Oh, and let's comment out ellipse mode corner. Okay, it's a bit much. Maybe it's too much. Okay, b divided by 6. Cool. So the darker the value, the smaller the circle. The lighter the value, the bigger the circle. And then it doesn't have to be C. Let's just do this as black. And we can do this as 30 instead of 60 for the size. Okay. So you might run into this issue where it says exiting potential infinite loop. To override that, you can do / / no protect at the beginning of the loop. And this might cause some issues if you are looping through every pixel, then you might crash your browser just because it's a lot for it to process. So that's why we're doing every 30 pixels or every 60 pixels. Otherwise, it's just going to be too much for the computer and the browser to process. There we go. But you can override that error message by just saying no protect before the for loop. Cool. All right, so you could also do this and apply it to really any other value. It doesn't have to be an ellipse. It can be text if you wanted to. It can be emojis if you wanted to. Let's actually do an emoji. So I'm gonna do mask emoji. Okay, so there's the mask emoji, which is appropriate for quarantine. So I'm gonna copy that. And I am going to apply that instead of the ellipse. So I'm going to comment out the ellipse. Let's do a text of emoji and x times s, y times s. And let's change the size. B divided by 6 based off of the brightness. So I just made a mirror out of mask emojis for the pandemic. And it's just changing the size of the emoji based off of the brightness of the pixel that it's analyzing. And again, it's a little choppy just because of how many pixels we're looking at, and probably because this is a fairly complex graphic element. So let's stop that and let's try 60 again. Okay, that's a little faster. Not as detailed, but it's okay. Cool. So emoji mirror. Looks good. All right, let's say we wanted to do a couple of emojis. So let's find another emoji. Let's do sneezing emoji. Okay. I'm going to copy that, go back here, and I'm going to create an array of emojis. Emoji. So let's do the sneezing one, and then let's do the mask one. Then in the double for loop, let's create another variable called e and set that equal to emoji x plus y modulo 2. So modulo is going to divide 2 into whatever this value is, and it'll give us the remainder. So if it divides in and it's an even division, then it's going to be 0. If there's a remainder, then it's going to be 1. So it's going to alternate between 0 and 1, which is going to alternate between these two emojis. So then we need to apply that variable to the text here, and we should be able to alternate between the two emojis when we play the video. Yes, cool. So now it's alternating between a sneeze and a mask. All right, let's stop that. So one more example. So we are going to play around with creating a photo booth. Basically just taking the live video feed that's on our canvas, and then on mouse press, we're going to save the current image as a JPEG. That's all we're going to do. Cool. Why don't we start from scratch? I'm going to create a new document. Okay, so let's create a new variable, var capture. And let's change the canvas. I'm going to do it half the size this time rather than the full 640 by 480. So we play around with the size function too. So let's do 320 by 240. All right, and then capture is equal to create capture, pass in video variable, then capture dot size. We could change the size of the video to be 320 by 240. Okay, let's change the background color here to 0 and see if that works. Okay, great. So we have a smaller video, 320 by 240. Stop that. All right. So the next thing we want to do is apply that video feed to our stage, to our canvas, using the image function. And you could pass in just the X and Y values, and the width and height will be whatever the default is. In this case, it's 320 by 240. Let's see if that works. Cool. All right, let's stop. And we can hide the second video, the DOM element. So it should just be 1. Cool, looks good. All right, so now we can just create a function for mouse pressed. So basically what we're going to say is when mouse is pressed, we want to save the canvas. And give it a name. It's called my canvas. And why don't we add a count to this? So I'm going to create a variable at the top, and it's going to be called count.jpg. Okay, so we're going to create a count variable, set that equal to 0 on load. And we're going to apply that count to this naming structure. And then we're going to update it every time we click the mouse. All right, let's try that. Click. Okay, let's save that. Click. Save that. Click. Save that. All right, show it in Finder. Cool. Okay, so if we wanted to, we could try and add a tint to this. 255.0.0. All right, so it looks like there's a little bit of an issue here. I think there might be an issue with the capture size. Let's comment that out. Okay, that works. But now the video is 640 by 480. So let's change let's apply the width and height of the canvas to the capture image. Okay, that seems to fix it. I'm not sure why it was causing an error with the size function. So that's something to be aware of. And then you could also pass in other things like filters or other elements, or applying text on top of the live feed, or other graphic elements. So you could do a lot of really interesting stuff with it. So one other thing that you could look at that might be helpful for project ideas or example code is Kyle McDonald has a pretty robust list of examples broken into different skill sets that is all based on P5, which is definitely worth checking out. So there's background subtraction, play around with brightness, change the threshold of that, black and white, and I think if you click edit, yeah, then it goes to the P5 sketch. There's other examples on here, like edge detection, which is really interesting. You play around with the threshold of that too. Here's face tracking is this video. Yeah. So it's tracking my face and looking at my eyes and mouth and nose and tilt. It's pretty detailed. And then there's some machine learning examples too that are worth checking out too. I'll go over some of these when I talk about machine learning and the ML5 library in the next video. All right, so that's all I have for this video. Like always, if you have any comments or thoughts or suggestions, feel free to add a comment on the YouTube channel or email me directly or Slack me. I'm always happy for feedback and always happy to answer any questions you might have. Thanks guys, and enjoy playing around with the webcam and computer vision, and I'll see you in the next video.